Hello everyone, welcome back to Z Physics. Today we are going to be talking about energy levels in gas atoms. Now, in order to illustrate this, I've drawn over here the first three energy states of the hydrogen atom. Now let's go over some of the basic rules that help us deal with energy levels. Now the first rule is that an electron cannot have a level which is in between energy levels, and this is really important. It's one of the cornerstones of quantum mechanics, but only certain energy levels are allowed. Now the next bit is also really important, and that is that you're going to notice that those energies over here appear to be negative. Now the reason why they are negative because external energy is required to remove an electron from the atom, and this is really important. The idea here is that if an electron goes up in energy and eventually reaches zero, let's say somewhere over here, it might reach 0 eV, then as soon as it reaches 0 eV, it is said that the electron has broken free from the atom. It has been ionized. So on the other hand, the energy level with the most negative value is known as the ground level, or also as the ground state. In the case of hydrogen, in this case, this will be this state over here, and 1, which is minus 13.6 eV. Here is where it gets really interesting. Now imagine that you have an electron that's been excited to a higher energy level, and let's say that it is at minus 3.4 eV, and then it loses its energy and then goes down in energy level all the way down to the ground state. So if an electron goes down in energy level, that energy has to go somewhere, and then a particle of light known as the photon is released. On the other hand, if we have an electron which is already in the ground state, it's at its lowest energy, and then we bombard that electron with some photons, this electron could jump an energy level. So from minus 13.6 it will go up to minus 3.4. So if that's the case, this is an indication that a photon has been absorbed. This is just pure energy conservation. So in this case, in which a photon is emitted, the electron will go down in energy level. If it goes up in energy level, that means that that energy has arrived from somewhere, so a photon, a particle of light, must have been absorbed. Because this is energy conservation, in both of those cases our change in energy, so we can write this as delta E, will be equal to the energy of the photon. So we can just say that this is equal to the energy of the photon. We know two formulae that are going to be useful in this case. From our first year quantum mechanics, we remember that that the energy of a photon is either hf, or we could also write this as delta E is equal to hc over lambda, where c is the speed of light, h is Planck's constant. In each of those cases, we can use these two formulae to work out either the frequency or the wavelength of the photon that has either been emitted or absorbed. In both of those cases, the change of energy between the energy levels will be equal to either hf or hc over lambda. Now let's use this formula to work out the frequency of the photon that has been emitted. Now in order to go from minus 13.6 to minus 3.4, I need to input 10.2 eV into the system. So I can set this number 10.2 eV equal to hf, and all I need to do really is rearrange for the frequency. Before I do that though, I need to be very careful, because if I want my frequency in hertz, I need to make sure that I've converted this from electron volts to joules. So remember, the conversion factor is the elementary charge, so this will be equal to 10.2 multiplied by 1.6 times 10 to the power of minus 19. This will be equal to Planck's constant times the frequency. This means that the frequency of this photon will be equal to 10.2 times the elementary charge, 1.6 times 10 to the power of minus 19, and we're going to be dividing that by Planck's constant, which is 6.63 times 10 to the power of minus 34. And if we put that into a scientific calculator, we are going to get about 2.46 multiplied by 10 to the power of 15 hertz. Okay folks, so hopefully energy levels make sense. If there are any questions, feel free to drop a comment down below. Thank you very much for watching.